Hello everyone, welcome again in Eng-Man YouTube channel. So we will continue our learning on PVTP software for retrograde condensate modeling. All right, in previous video we have done the regression, and we can improve significantly the quality for the matching of the phase envelope or the saturation pressure. If I may show you, double click on phase envelope, results plot here. So the orange curve is the new fluid model from regression. And you can see we can reproduce the saturation pressure here. Okay, so now the next step, we want to check or we want to validate the result for the separator test. Double click on this, results table, and then stage results. And let's compare it with the sample. Once again, double click here, enter lab data, separator. Okay, interesting. All right, so for the data is 5,919, whereas our result, the first after the pseudo properties, is 6,028.5. But what we want for now actually is here. So select fluid regression. All right, so now it's very close. Stage GOR 5,920, which is very close with the data. So the error, the percent error, is very small. And what about the second objective, which is the oil density? Oil density 771, and based on our fluid model, we get 770.7. Okay, so it's very close. So you can say that the validation is successful for the separator test. So we can reproduce the saturation pressure. That's the first thing. We can reproduce very closely the liberated GOR, gas oil ratio, from the separator test. And then we can also reproduce very closely the oil density. Okay, that's it. That's very good for the separator test. But from the separator results, it is also possible to drill down farther into the stage-by-stage results. For that, we can go to here, detailed results. And again, we have for the select fluid, pseudo properties, or regression. And select stage, we have two stage, the first one and then second one. And then on the right side, we have the flash results. You can view the composition like this. You can also view the phase properties and then the Hoffman plot. All right. You can go through the stages and investigate how the composition of the vapor and liquid phase changes after each stage. Additionally, it is possible to plot the Hoffman quality plot. Yeah. To check whether a physically consistent flash is performed. So let me expand this. All right, so first, this is the Hoffman plot, Hoffman quality plot for the pseudo properties at the first stage, and then at the second stage. That's for the pseudo properties. But the main thing here, the one that we want, is actually the regression. First stage and second stage. And you can see we can sort of produce a linear trend. If the lighter components all line on a straight line, then this means that a consistent flash is calculated. Heavier components, however, or the last pseudo components can deviate from the line of best fit. So you can see the heaviest components there. So it turns or it deviates from the straight line. Okay, but that's okay. The most important thing is the lighter component. So you can focus more on the upper right side here. If the lighter components lie on straight line, this means that a consistent flash is calculated. Heavier component, like the last pseudo component, by the way, can still deviate from the line of best fit. This is for the first stage and second stage. So we can say that based on the Hoffman plot, which is the log Kp plotted against the B function, we can say that the quality plot both for the pseudo properties fluid model and the regression fluid model are acceptable. If we have extreme curvature can be a sign of data inconsistencies. However, as most components are on or close to the straight line here, this suggests that the calculated K values are actually consistent. All right, so that's for the validation of the separator test. So to conclude, we can reproduce the saturation pressure, and then we can reproduce the first stage GOR. We can closely reproduce the density. Where are you? Yeah, for the regression. And then lastly, we can produce a good or a representative Hoffman quality plot. All right, and that's it. In the next video, we will check or we will validate the result from constant composition expansion. Until then, thank you and see you.